Andre explain briefly this topic that I personally don't understand, but I hope that you will.
Yes, the view is that consciousness is quantum mechanical.
Do you want to explain that?
Yes. Yeah, without going into the argument, basically is that there's like some specific information processing component of consciousness that actually requires quantum mechanics to be explained.
Okay.
Yeah, my position is that you don't need quantum mechanics to explain that particular aspect of consciousness. Now, just to be clear, we're not going to discuss everything about consciousness because there are a lot of different things we could be discussing. We're specifically going to discuss this thing called global binding. So how do you have a unified percent of, let's say, yourself in the universe with a sensation of what's going on? That is not just a matter of putting together bits and pieces of your, let's say, visual perception and auditory perception and having a fragmentary sort of experience, but instead a unified percent.
Okay, so we're going to have a vote now. How many people agree with what Andre said? I personally agree with Andre, so go ahead. No one agrees with Andre. No one agrees with Andre. Okay, we got someone else. Do we have a third voter for Andre? Are you keeping track of this, Scott? It's not a big number, but it's... Okay, everybody who agrees with Andre. I think we're up to 5. We're up to 6. We want to have this competitive.
How are you counting? I see like 2.5.
Everybody's kind of wimpy on this, but I saw 6. You don't see 6? 1, 2, 3, 4, 5, 6. I see 6.
Okay.
6 for Andre. Okay, I'm assuming we have... Okay, how many agree with what Randall said? Okay. Oh, that's a big number. Someone's going to have to count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11. I got 11. Mike, and how many people just have no clue about how they feel about this?
I didn't think that the presentations were clear enough to make a decision as to what they were talking about.
Okay, well, we're going to...
So we'll count you as having no clue.
Okay, but you got those numbers down.
Oh, maybe I vote for how many are neutral.
How many people are neutral? Because we can...
I want to speak up.
1, 2, 3. We got 3 neutrals. Okay, go ahead.
Look, you can't explain, if you go deep, you cannot explain ordinary chemistry, including the chemistry of the mind, without quantum. But I think I'm thinking he's speaking to, there's something like quantum tunneling in neurons you have to invoke or something?
All right, Rick, you're for Andres. We're counting you for Andres based on that statement.
We want to keep in the order here.
Let's check that
Here's how
out.
we're going to proceed on this. What we're going to do is Andre's going to talk 7 minutes, then Randall's going to talk 7 minutes. Andre's going to have a rebuttal for 3 minutes. Randall's going to have a rebuttal for 3 minutes. Audience is going to ask questions of both of them for 7 minutes, and then we're going to vote. This is Scott over there. He is our timekeeper.
When you have like a minute, I'll give you a minute, and then 30 seconds.
Okay. All right. So we're going to start off with Andre. Ready, go.
Hello, everyone. All right, yeah. So first of all, thanks for inviting me. So I would like to clarify the view that I present. It's completely unrelated to like Deepak Chopra, The Secret, Oprah, etc. Which is kind of a problem because usually when I talk about these things, people just immediately pattern match to like that space. The kind of inspiration that I actually draw is like real philosophers like Michael Lockwood, David Pearce, Galen Strawson, etc., who have made I think like a pretty strong case. Okay, I'm also aware that the view that I'm presenting is very unpopular, and it goes against the current neuroscientific paradigm. And I think like it's good that you guys know that I'm aware of it. It's like I grew up being a functionalist. I used to think that basically all that mattered for consciousness was the internal causal relationships that happen in the brain and the information processing that derives from that. I used to think that really there was some kind of mapping between conscious states and specific information processing elements, which is really convenient for something like transhumanism because that allows you to basically create a program that creates consciousness in a sufficiently advanced computer, but without having to use quantum computing and instead just use classical computing. However, I changed my view by talking to David Pearce at Stanford when I was studying cognitive science over there. I invited him to give talks about consciousness and ethics. And David Pearce basically pointed out that my functionalist account of consciousness simply doesn't have the proper ontology to make sense of what's understood as phenomenal binding. And phenomenal binding is basically decomposed into three sub-concepts. You have, on the one hand, local binding, which is the idea, or like the actual part of your experience that puts together various features of your own consciousness into unitary phenomenal objects. So when I look at my hand, I don't only see shapes and colors independently. I see the shapes and colors together into a unitary phenomenal object. And we may not realize this is going on, but when actually your brain breaks down, or you take ketamine or like some other chemical, local binding breaks down. And all of a sudden you see colors and shapes overlapping, but not as part of the same object. So there's like some interesting phenomena going on that is unifying the various features of consciousness. Then you have the subject of discussion today, which is global binding, which is the philosophically most interesting aspect of binding, which is how different phenomenal objects are perceived simultaneously into a unified field of awareness. Now, many people take issue with the word simultaneity here. People say, hey, like, you may think that consciousness, the various perceptions of your consciousness occur simultaneously, but in reality, it's like a sequential process that gives the illusion of simultaneity and so on. But people who argue that are not making the proper distinction between two important psychological processes that are independent. One is called awareness, and the other one is called attention. When you open your eyes, within 200 milliseconds, you already have an awareness field of what you're looking at. The awareness field locates particular features of the visual experience in a unified visual field. And attention happens after half a second or so, where you start paying attention to clusters of features and putting them together into unified perceptual objects. So global binding actually goes before something like local binding. And there is the illusion that actually consciousness is sequential, not simultaneous, only if you identify consciousness with attention, rather than recognizing that awareness is another key element in consciousness. Now, there's a final kind of binding, which is called neighborhood binding, which is how the different features in your experiential field are spatially related to each other. But that's like another subject that's just important to point out. And now, what is sort of like the current contemporary neuroscientific account of like global and local binding? Well, it usually goes in one of two ways. You have on the one hand what people call sort of like synchrony, and on the other hand what people call implicit information processing. And my claim is that neither of these actually account for the unity of consciousness. On the one hand, synchrony, you have the claim that synchronic activation of different regions of the brain that encode, for example, the color and the shape of the perceptual objects that you experience, that because they happen at the same time and they interlock with each other, there's like some kind of important functional unity here. However, what I want to point out is that functional unity is not sufficient for the kind of unity that we experience. We experience something that can better be described as ontological unity. The various features in our conscious experience are fundamentally part of a unified experience, which is different than just behaving as if they were unified. And just like one way of sort of like showing a thought experiment, you can imagine if you just like separate the brain into pieces throughout the galaxy, you can have all the synchrony you may want between these components, but that would not actually make them unitary in any meaningful sense, because you still have the speed of light and they can't overcome that. However, something like quantum coherence, entanglement, can enable something like an ontological unity, because the ontology of quantum mechanics has such a thing as ontological unity. And I just want to sort of like finish up with this last minute I have, sort of like explaining a common misconception about science, which is basically that sort of like philosophical speculation or philosophical argumentation really doesn't help for science. And that is true when you are within a given paradigm. Sort of like if you read The Structure of Scientific Revolutions by Thomas Kuhn, within any given paradigm, philosophical speculation is not very useful. But in order to advance to a paradigm that actually incorporates more pieces of information that seem to be dissonant within the paradigm, you actually require philosophical reasoning. One example of this would be like Galileo creating an entirely new paradigm by philosophically thinking about what happens if you take one object that is really heavy, you let it fall, and now you break the object into two pieces and you add a rope between them, and you let it fall. If heavier objects fell more rapidly, the second object should fall more slowly, but it turns out they fall at the same speed. Yeah.
Good, very good.
Is this on? Yeah? I think you really need it. Okay, so first of all, Andres is right about something. He's right that we have to focus on the fact that this global binding of the unity of percept has to really produce unity in some sense. It can't just be that you say everything is synchronous and that's enough. Neither can you just say everything is part of a quantum wave function and therefore it's somehow a unity. I mean, how does that make it more of a unity that it happens to be part of that wave function than if you say it's part of one synchronous operation, right? So really the problem here is that he's focusing on the wrong part of what it means to talk about unity. You don't try to make a hypothesis for a belief in one particular outcome. For example, the fact that this is based on quantum mechanics. You try to make a hypothesis for the evidence that you have, for an experiment. So for example, a simple experiment like your report that you just had a conscious experience, conscious awareness. That report though, keep in mind, is post hoc. It's based on something that you interpret at that point and say about your experience. And in this case, it says, it seems like my experience was unitary. It seems like all of the things that were going on had an impact on how I feel about this. It seems like everything from my visual, auditory, etc. is all part of this same experience that I have, of the feeling that I have, the sensation of being here. But keep in mind that this is about causation. That report, giving that report means that you are already making a judgment. You're determining something. So basically, you're saying whatever happened there, all these different parts that were going on, somehow all contributed to this output. Now, Andres is right when he says you have to explain how that can all happen together, and he brings in light speed and says there's nothing else that can overcome light speed. But the truth is there is something else. Because when we talk about this kind of causality, what we often do, let's say for example we're looking at computers where you have a clock. The clock taking the computer from one moment to the next. One state of the computer affects the next state of the computer. As long as you have that kind of a discrete process, there is no time in between from the perspective of the computer, and everything in the first state affects the second state. So if you're going to make a determination then about whether you had a conscious experience, the answer is yes, and everything was one unitary experience. And by the way, there's some really great work by people like Susan Blackmore, if you watch their videos, showing you how you often do this retrospective look back at what you were experiencing and whether you were conscious before of what you were doing. So I really recommend that you take a look at that. Now just to give you an idea of how you can have the basic zero-time light speed communication between neurons if you just have a discrete process. In the brain, we have a number of different things that make that possible. First of all, like Andres said, there's synchronization. But what does that really mean? What it means is that you have a number of things in the brain that help you keep discrete states separate. In certain modes, for example, when you have working memory going on. So that's a very typical thing when you're doing deliberate conscious action. So when you are consciously aware. What happens in those states is that you have something called theta rhythm. Theta rhythm repeats at about 125 milliseconds. That gets you approximately in that 200 millisecond approach piece that Andres was talking about, where you get a percept of the world. And within that period, the pyramidal cells in the brain, they can reactivate. So if they've had a pattern active before, they get after depolarization, and the same pattern comes up again, but it's synchronized with the theta phase. Also, these pyramidal cells, they feed into an interneuron network that produces lateral inhibition, recurrent lateral inhibition, that suppresses the activity after a pattern bumps up. So you don't get another pattern right after that. There's at least about 12.5 milliseconds before the next pattern can come up. And that's really important, because that discretizes what's going on in the brain. Now, what you have is, every 125 milliseconds, pattern reappears. You can have a second pattern in that slot, and a third pattern in the next slot. So you have room for what is it, the short-term memory capacity of like 4 ± 1 items, or sometimes they say 5 ± 2, depending on exactly what's been measured.
And that fits right in there. There's tons of stuff that is online, you can see about that. Listman et al., just recently, Earl Miller published about it. There's tons of evidence about this. Now think about this. If you have a discretized process in the brain, then from the point of view of the next pattern that bumps up, all of the previous pattern, no matter where it was in the brain, has had enough time to propagate its information to the other neurons it's connected with. So from their point of view, from the next pattern's point of view, all of that information has already arrived, and you might as well have arrived instantaneously, with no time in between. This gives you global binding. So there's a global binding method you've been using classical neuroscience without quantum mechanics that deals with this problem of propagation. There's also an interesting corollary to this, which is that I don't think P-zombies can exist, philosophical zombies. Because consciousness, in this case, is not an epiphenomenon, but it's really something that you need in order to be able to process the world as a whole. Imagine what you would do if you didn't have global binding. If you didn't have global binding, then you couldn't take all of the disparate parts of what your brain is receiving into account when you're trying to process what to do next. So global binding is probably really important, but global binding depends on these very basic processes, such as the nested oscillations, the repetition, and the lateral inhibition that I was just talking about. So if you have, say, an upload that doesn't have these processes, there would be no global binding, so you wouldn't be able to do the sort of things that people normally do. Hence, they wouldn't behave the same. They wouldn't be, they wouldn't appear to us as complete humans. And that basically means that philosophical zombies would not appear such as us. So you can't make that mistake. Anyway, yeah, thanks.
Are you going to cede back? You have a minute. Are you going to cede it?
Sorry?
You're going to cede back your minute? You have a minute.
I'll give my minute back.
Okay.
Okay, Andre's got 3 minutes for rebuttal.
All right. Thank you. Yeah, this is exactly the level of discussion I like to discuss this. So Randal actually provided a really good point, which is that yes, there seems to be some discretization to global unified states of consciousness, where the current pattern in your brain, there's a discrete period of time between that and the next one, and all of the information in the previous one does seem, at least neurologically, to propagate into the following one. And in that sense, you can think that, hey, like the current state is fully aware of the previous state and all of the information. And hey, maybe that way you might get global binding. However, this actually has a problem. It's just like shifting where the problem with global binding is. On the sort of like the thing that it is addressing is like how one state can be, in a sense, fully informed about the previous state. What it's not explaining is why the current state is unitary. Because in the end, it is a pattern of activation that is like spread around many centimeters in the entire brain. And somehow, even though the pattern in and of itself contains all the information of the previous state, you still need to interpret that pattern. You need to go neuron by neuron and say, is this active, is this not? And somehow integrate all of that information, which sort of like brings to sort of like the core of the argument, which is a philosophical concept that's called mereological nihilism. Is the idea that basically there are no things with parts. And this is like counterintuitive at our level, but in quantum mechanics, this is actually like apparently true. The universe is composed of quantum wave functions that interfere with each other and get superimposed with each other. And a particular wave function is unitary. If you modify it in any one part, all of its behavior changes, which is not the same with classical systems, where if you modify one part, you actually need to wait for information to propagate to the rest of it. So let's think about it like that. If you have like your particular state of your brain, which creates a particular state of consciousness, all of the information in your state of consciousness are currently unified. And if you were to change any one part of it, the entirety of your conscious experience would change. However, in a sort of like classical description of a brain, if you change any one part of the brain, that information doesn't propagate until the next cycle. And then you still have the question, how did that snapshot became unified? And yeah, I'll just conclude by saying that there is a fundamental difference in sort of like the unity between what's called like functional unity and ontological unity. quantum mechanics allows ontological unity, our consciousness is ontologically unitary, whereas classical mechanics simply don't allow ontological unity.
Okay. I don't think Andres understood what I was saying about post hoc, that this is about a causal post hoc realization, the report that you gave about your consciousness. Because even the fact that you're feeling conscious right now, and that you tell yourself, yes, I feel conscious, is a post hoc report. And by the way, this all fits right into the Libet experiments and everything else, which is this: you do have unity. You have the unity of all the information that was available at the previous state to make your next state. And that is what the experience of consciousness is. It is not some other state that you somehow have to perceive of all the neurons and what they're like right now. By the way, the quantum mechanical solution does not make that go away. By the way, it just throws up new problems. So for example, if you don't have, if you've got this unity through the quantum wave function, why would that unity stop within your brain instead of, say, over to all the other brains and everything else that's out there? Isn't the entire universe describable as such a wave function? So how do you say this is just your consciousness, or this is me versus you or anybody else?
Just accept
And
that.
on top of that, you've got other new problems, like how do you even carry out this quantum function of the brain? And if you go through all the various theories that are there, first of all, there's basically no evidence. And there are so many counter evidences, such as, decoherence and all kinds of other stuff. So, plus, if you look at the brain and what it goes through, just to try to make itself reliable, so that one part of the brain can talk to the other, you're not depending on these tiny, minute fluctuations of whatever's going on at the atomic level, not even at the molecular level. You've got unreliable synapses, unreliable neurons. It is a whole bunch, like using tons of neurons together, bursts, and all of that stuff, just to try to make itself a little bit more reliable at that level. So I think the evidence is really hard against quantum mechanics being useful for this, plus it doesn't solve the problem. And in fact, I think that just understanding that there is an illusion at play here, and the illusion is that you think that you're experiencing a state, when actually what you're experiencing is a dynamic process. It is the result of what has happened, the comparison between the previous state and the current state, the activity, the comparison. That is what you're then determining and judging by and saying, oh, that was my conscious experience.
Very succinct. Give you another minute, okay.
We have 7 minutes for questions, and we have a question right here from Mike Johnson. Go ahead, Mike.
Yeah, thanks. So it seems like a big question mark here is, how do you draw the line of where the boundary between a conscious system is and the rest of the world? And I may be putting words in Andres' mouth, but he's saying that things have some sort of special quantum relationship within a conscious system, and that relationship is not held outside the system. And I don't want to put words in Randal's mouth for how he draws the line. And I'm wondering if you could each say a little bit about that.
Yeah, I would say that actually the problem of at what point do you consider the boundary of your consciousness is found and where the rest of the world is, that's a much bigger problem if you think of a classical account of consciousness, because you have basically that problem within the brain as well, unless you invoke some kind of implicit information processing as the unity of consciousness, whereas the quantum mechanical account actually has an objective, these components are part of the unity, and those components are not, such as in a quantum entanglement for quantum computing. You can define these are the components that are unitary, and those are the ones that are simultaneously affected if you modify any part of the system.
Well, what do you say to quantum entanglement doesn't work in the brain because it only lasts for femtoseconds?
Yes, Tegmark calculated that quantum coherence decoheres in 10 to the minus 13 seconds in the brain, which is undoubtedly a strong point against quantum mind, and I totally acknowledge that. However, I would still say that the philosophical argument is strong enough for us to consider seriously the possibility that actually what's going on is that there are 10 to the 13 snapshots of consciousness in every single second.
I would say the philosophical argument for the importance of local binding is big enough to think about actual possible hypotheses and to think about ways this could work, but it does not necessarily support quantum mechanics. I mean, there's so many other things you could explore instead to solve that problem, right?
Well, there are other possibilities you can explore to account for the functional unity of the mind, but we're talking about ontological unity. And then again, my success rate in communicating the difference between ontological unity and functional unity is like about 1%. So I don't really expect people to believe me. It's just like, I'm pretty sure there's a difference. It took me like about 7 months to understand the difference.
Let's take another question. We're going to go with Anya here, then you, and then you. Go ahead.
I remember when I was reading the work by Penrose and Nemiroff, they had an interesting idea that kind of struck me as a curious solution for this problem of a necessity to have a conscious observer for the wave function to collapse. You know that the cat is dead or alive, but I look at it. So they basically proposed an idea that reconciles that paradox by saying that the collapse of the wave function is the moment of consciousness. I was wondering.
Yeah, but that's kind of a flawed interpretation about how collapse of wave function happens, because when they talk about an observer in physics, it's not about a conscious observer. The observer is a measurement. Anything that does a measurement is an observer, so it does not have to be a conscious person.
But measurements involve a conscious observer. You can have a measurement without a conscious observer.
No, you could say that an interaction with something else is a measurement. If something needs to interact, if you need to find out what's going to happen over here, then you need to know what the state of this was. So you've already measured what that state was in order to have something happen on the other end.
Well, from what I understand, the point was that like in the very dawn of quantum physics, when they started thinking about it, the idea is that I'm sitting in a room and there's nobody behind me. Like, is there stuff behind me? When I look at the stuff, it suddenly materializes, so to speak. The wave function collapses, and the act of me seeing the exchange of the photons between my eyes and the object is the act of measurement.
And I think most physicists will disagree with you about the Penrose and Hammeroff interpretation.
So I have like a couple of things to say here. Like that relies on basically what's called the Copenhagen interpretation of quantum mechanics, which like it's not something I particularly think is, I don't think is likely. I prefer like the aberrant interpretation of quantum mechanics, where actually the world is made of quantum coherent wave functions and the collapse is an illusion, basically. But however, Hammeroff and Penrose did propose something really interesting, that there's like some overlap with kind of what I'm saying is not exactly the same, but there's like one point that actually is really interesting is that they propose that there are topological structures in the cytoskeleton of neurons that shield against quantum decoherence, because they are sort of like knit together in such a way that they don't really interact very much with the environment of the cell. So that's an interesting possibility of like how we might get like, instead of like postulating 10 to the 13 snapshots of consciousness, it might be 10 to the 6 or so per second.
The Orsho R model has a ton of problems, and probably the biggest one is purely experimental, which is that, so basically Hammeroff claims, yeah, this is my explanation for how anesthesia works, because microtubules are involved, and you know, if they get disrupted, then your consciousness goes away. But if you go into an MRI, your microtubules, their state gets totally disrupted, but you know, you don't lose consciousness in an MRI.
Yeah, that's a good point.
I think we need to move on to Rick's question.
Yeah.
Is that Rick? Right. Okay.
Yeah. So, if I understood something you said, Andres, which may not be true, that I maybe missed it, but you were claiming that there's a speed of light issue around the behavior of the brain. Now, my understanding is the speed of light is about a nanosecond per foot, and my brain is about a foot across.
Yep.
Is there any evidence for a synchronization of phenomenon across the brain at a nanosecond time scale? And on top of that, quantum mechanics doesn't give you faster than light signaling anyway.
No, quantum mechanics doesn't give you faster than light signaling or communication, but it does give you unitary objects that are interacting with parts of the universe that are very far apart, while still being a unitary object. And that is what you need to account for consciousness. And I would say like the evidence that this simultaneity is actually going on is right in front of your eyes in your, like the nature of your conscious experience.
That's not the evidence that you have at all. The evidence that's right in front of your eyes is that you have drawn a conclusion computing over what just previously happened. Because that's the only thing you can report, even to yourself, is what you have already concluded. Sorry. And also, the quantum mechanical description of the universe, or any mathematical description of the universe, great that you can put everything into that description or representation, be it a wave function of whatever else. But that doesn't even give you like a unitary perception for a human, or what that means, as opposed to say any like conglomeration of something.
We're gonna grab Mike's question. Mike's, yeah, are you Mike? Your name is Mike?
No, Alex.
Alex. Alex. Okay, go ahead. Your question.